This is the coolant pump that come with my Harrison lathe. It's obviously a replacement pump because this one's plastic. The original pump would have been metal. The motor on the pump is dual voltage, 440, 230. And what I want to do with this pump, I want to run it on the lathe and the milling machine. So I want to try and convert it to run on 240 volt mains, single phase, instead of 440, 3 phase. The reason being, I don't want to have to run the rotary converter just to run this pump when I'm using the milling machine. We'll have a look inside the motor and see what sort of wiring connections are in there. See if it'll easily convert to single phase. Right, that's the plate on the motor. It says there 230, 440, 3 phase. We'll take the cover plate off. Right, straight away I can see we've got the 6 ends of the wires, or the coils of the motor, and it's actually at the minute wired in star configuration for 440 volt. This will easily convert to delta for 240 volt, and there is a way of running it on single phase. There's even a wiring diagram in there which gives you low voltage and high voltage. High voltage is star, low voltage is delta. All we need to do is take the nuts off, and these two bridging pieces go from, instead of being that way, they go that way in 1, 2, 3, join them all together, and that way the motor will run on 3 phase 240 volt. There you have 3 phases there, 1, 2, 3. What you normally find is you get 3 of these. Of course there's only 2 here, so I want one across there, one across there. I'll have to make another one for there. Right, so we'll put our 3 link bars across. It's now wired in delta configuration, and that's where the 3 wires from your 3 phase supply would go. So we'll have to generate the extra phase. To do that, we'll use a capacitor. These are our live and neutral, our normal 240 volt single phase supply. That's the earth. This motor is double insulated, so it hasn't got an earth. What I will do, I'll put the earth onto the water tank, which is also earth to the lathe. So they go through there. Right, here go to any 2. Right, we're live and neutral. So now we need to generate extra phase for this one. We'll do that by putting a capacitor between any one of those and that central phase. Right, I've got a capacitor here. We'll link this in to the centre phase, or the phase that hasn't got any power to it. Then any one of the other 2. If you find the motor's running in the wrong direction, you can simply swap any one connection over, and that will reverse the direction of the motor. got to be aware that that's 240 volts in here you're playing around with. Right, so we've configured it, or we've reconfigured it from star wound to delta wound through a capacitor. Right, we want it to go that way, which is clockwise from this end. It's going anti-clockwise. You can hear the motors run quite happy. I'll turn them two around and get it run in the correct direction. Right, to change direction, we'll take that one off there, put it onto that side. Right, it's now running in the correct direction. Loads of torque. It sounds nice and quiet. Right, I want to check the voltage across the windings. So the first one will be this one, which should be 240, 238. That one there, 270, and that one 260. So the voltage aren't too bad. What you can do, you can play around with different values of capacitor and get them all running more or less the same. There's probably a formula for working out what size capacitor to use. I'll just experiment. And this motor is running at a very low load. Well, it's only a cooling motor. Check them again. That's a straight mains in, 238. That's one phase, it's 270, and the other phase is 265. That'll run happily like that. Obviously I'll build a box for the capacitor to go in, and all the wire will be tidied up, and I will put the earth onto the water tank. Although the motor's double insulated, putting an earth on can't hurt.